cost management practices. We all know that cutting costs is the simplest way to improve your bottom line, but cost control needs to be carefully managed. In this lesson, we will explain value analysis and value engineering, discuss business process reengineering, describe total quality management, and explain cost reduction and control. After going through this presentation, you should be able to explain value analysis, value engineering, business process reengineering, total quality management, total productive maintenance, and cost reduction and control. Value analysis is an effective tool for cost reduction, and the results accomplished are far greater. Value is equal to worth to you divided by price you pay. This means that if you feel that you have the money's worth, then you have received 100% value. Value is the least cost that can accomplish reliably a function or a service. Value can also be defined as that combination of quality, efficiency, price, and service which ensures the ultimate economy and satisfaction of the purchaser. Value analysis job plan is the systematic approach which is more important to achieve the desired objectives. The phases of VA job plan are selection and orientation, analysis, recording ideas, speculation, investigation, recommendation, and implementation. The application of value analysis only needs to make use of basic techniques such as matrix, Pareto chart, Per and Gantt diagrams, etc. Value analysis can be applied universally, that is, to everything: materials, methods, processes, services, etc., where it is intended to bring about economics. Value analysis is a staff function, like, for instance, industrial engineering, and should be organized as much. It should be directly under a high-ranking officer from the senior management of an undertaking. This is necessary because value analysis concerns all departments and the analyst must have access to them and to their records, performance, costs, etc. Value engineering is the term applied to value analysis, done the design and prototype stage of a product. Value engineering (VE) is a systematic method to improve the value of goods or products and services by using an examination of function. Value engineering is sometimes taught within the project management or industrial engineering body of knowledge as a technique in which the value of a system's outputs is optimized by crafting a mix of performance, function, and costs. Value engineering began at General Electric Co. during World War II. Because of the war, there were shortages of skilled labor, raw materials, and component parts. Lawrence Miles, Jerry Leftow, and Harry Ehrlicher at GE looked for acceptable substitutes. Value engineering is often done by systematically following a multi-stage job plan. 4 basic steps in the job plan are: information gathering. This asks what the requirements are for the object. Function analysis. An important technique in value engineering is usually done in this initial stage. Alternative generation or creation. In this stage, value engineers ask what are the various alternative ways of meeting requirements. What else will perform the desired function? Next, evaluation. In this stage, all the alternatives are assessed by evaluating how well they meet the required functions and how great the cost savings will be. Next, presentation. In the final stage, the best alternative will be chosen and presented to the client for final decision. The value of the product slowly increases in development and growth stages as more features are added and desired changes and modifications are effected. The success of value analysis for one product, of course, is made use of in the design of other products by development wing. In the process of manufacturing, there are many material losses. which takes place, known as waste, spoilage, and scrap. Waste is defined as the substance having no value. Waste can be two types. First, normal waste and abnormal waste. Normal waste. It is the loss which is unavoidable on account of usual nature of material or processes, such as loss of coal due to loading and unloading process, or liquid lose their weight due to evaporation. Abnormal waste, any loss caused by unexpected incident or abnormal conditions, such as accident, carelessness, etc. Abnormal waste affects both the units of output and cost of output. It doesn't increase the unit per cost of output. Business process reengineering is a discipline in which extensive research has been carried out and numerous methodologies churned out. Business process reengineering involves changes in structures and in processes within the business environment. Reengineering is the fundamental rethinking and radical redesign of business processes to achieve dramatic improvements in critical contemporary measures of performance, such as cost, quality, service, and speed. Process is a structured, measured set of activities designed to produce a specified output for a particular customer or market. It implies a strong emphasis on how work is done within an organization. The most important action in applying BPR is the company's strategic goal to provide customer-oriented services. BPR is a technique used to implement this type of organizational structure. Empowerment means giving people the ability to do their work, the right information, the right tools, the right training, the right environment, and the authority they need. BPR is achieving dramatic performance improvements through radical change in organizational processes, re-architecting of business and management processes. It involves the redrawing of organizational boundaries, the reconsideration of jobs, tasks, and skills. When applying the BPR management technique to a business organization, the implementation team effort is focused on customer service oriented processes, aiming to eliminate customer complaints, speed, compression, flexibility, quality, innovation, and productivity. BPR is worldwide applicable technique of business restructuring focusing on business processes, providing vast improvements in a short period of time. Most reengineering methodologies share common elements, but simple differences can have a significant impact on the success or failure of a project. A BPR project consists of specific steps aiming to a successful outcome. Step 0 is preparation and coordination of the project. Its objective is to explain to the members of the BPR implementation team the implementation details of the project and their role in the successful outcome in the BPR effort. Next, step 1 is business diagnosis and measurements. Its objective is to measure the performance characteristics of the current processes based on measurable factors such as average cycle time, delays, number of mistakes, or number of customer complaints. Next, step 2 is selection of processes for change and modeling. Its objective is to identify the strategic processes that are feasible to change and redesign the selected processes. Next, step 3 is technical design of the solution. Its objective is to automate modeled business processes. Step 2, using networks and workflow tools and redesign and model the selected processes. Next is step 4. It is personnel adjustment and training. Its objective is to train personnel in the new ways of working using IT in the redesigned processes and redesign and model the selected processes. Next, step 5 is management of change and employee empowerment. Its objective is to minimize the resistance to change between employees by empowering their position based on performance appraisal and bonus systems. Next, step 6 is introduction of new process into business operations. Its objective is to set the time and date of operating under the new processes, emphasizing the fact that working under the old processes is not an acceptable practice. Next, step 7 is continuous improvement. Its objective is to capitalize from the BPR project and develop internal experts for other BPR projects. The expected outcome from a successful BPR process should the desired one for the favor of the business concerned. TQM is a management philosophy, a paradigm, a continuous improvement approach to doing business through a new management model. The TQM philosophy evolved from the continuous improvement philosophy with a focus on quality as the main dimension of business. The meaning of quality for businesses changed dramatically in the late 1970s. TQM recognizes that a perfectly produced product has little value if it is not what the customer wants. Another concept of the TQM philosophy is the focus on continuous improvement. The Plan, Do, Study, Act (PDSA) cycle describes the activities a company needs to perform in order to incorporate continuous improvement in its operation. Another way is companies implement continuous improvement is by studying business practices of companies considered the best in the class. This is called benchmarking. Part of the TQM philosophy is to empower all employees to seek out quality problems and correct them. A useful tool for translating the voice of the customer into specific technical requirements is Quality Function Deployment (QFD). QFD begins by identifying important customer requirements, which typically come from the marketing department. An important dimension of product design is that the product functions as expected. This is called reliability. According to TQM, a quality product comes from a quality process. This means that quality should be built into the process. TQM extends the concept of quality to a company's suppliers. Causes for TQM failure are lack of a genuine quality culture, lack of top management support and commitment, and over and under reliance on statistical process control (SPC) methods. Total Productive Maintenance (TPM) is a maintenance program which involves a newly defined concept for maintaining plants and equipment. TPM was introduced to avoid wastage in a quickly changing economic environment, producing goods without reducing product quality, reduce cost, and produce a low batch quantity at the earliest possible time. TPM originated in Japan and was an equipment management strategy designed to support the total quality management strategy. TPM thus began in the 1950s and focused primarily on the preventive maintenance. The TPM program closely resembles the popular Total Quality Management program. Many of the tools, such as employee empowerment, benchmarking, documentation, etc., used in TQM are used to implement and optimize TPM. TPM targets to obtain minimum 90% OEE to run the machines even during lunch and maintain an accident-free environment. TPM has the following 5 goals. First, improving equipment effectiveness. This goal, which ensures that the equipment performs to design specifications, is the true focus of TPM. Second, improve maintenance efficiency and effectiveness. This goal focuses on ensuring that maintenance activities that are carried out on the equipment are performed in a way that is cost effective. Third, early equipment management and maintenance prevention. The purpose of this goal is to reduce the amount of maintenance required by the equipment. Fourth, training to improve the skills of all people involved. Employees must have the skills and knowledge necessary to contribute in a TPM environment. This requirement involves not only the maintenance department personnel but also the operations personnel. Fifth, involving operators or occupants in routine maintenance. This goal finds maintenance tasks related to the equipment that the operators can take ownership of and perform. While the TPM flow appears to be easy to flow, there are hidden pitfalls when trying to implement TPM. First, organizational downsizing. In the business environment of the early 2000s, much of the management focus is spent on headcount reductions or downsizing of the workforce. This practice is detrimental to the employee involvement required by TPM. Next, lack of focus on results. Many consulting organizations that teach TPM focus on its esoteric aspects. They have their clients start by cleaning the equipment, forming teams to discuss theoretical improvements, and creating visual systems to make the plant look better. Cutting costs is the simplest way to improve your bottom line. The ICMA London defines cost control as the regulation by executive action of the cost of operating an undertaking, particularly where such action is guided by cost accounting. Cost control is exercised through setting standards or targets and comparing them to actual results therewith, with a view to ascertaining deviations from set targets and taking corrective actions to improve the future performance. Elements of a cost control scheme are set down a standard or target and select a benchmark for measuring the target. There are a number of techniques of cost controlling, but some are very popular for ensuring cost control, such as material control, labor control, etc. Controlling costs can be damaging. Before making changes, check that your standards will not be compromised and that your ability to meet objectives will not be harmed. Employees are not machines. The work performance suggested by time and motion studies is unlikely to reflect people's actual behavior. Production and marketing plans driven by cost-cutting considerations are unlikely to be responsive to customer requirements. Cost reduction is a planned positive approach to reduce expenditure. It is a corrective function by continuous process of analysis of costs and functions. The ICMA London defines cost reduction as cost reduction is to understand as the achievement of real and permanent reduction in the unit cost of goods manufactured or services rendered without impairing their suitability for the use intended of diminution in the quality of the product. A cost reduction program should be evolved with the idea that even the most efficient firms incur the unnecessary cost, so every firm has a scope for cost reduction. Cost reduction leads to increase in profit. It provides a base for more dividends to the shareholders, more bonuses to the staff, and more retention of profit for expansion of the business, which will create more employment and overall industrial prospects. Quality may be sacrificed at the cost of reduction in cost. To reduce cost, quality may be reduced gradually and it may not be detected till it has assumed alarming proportion. Bad quality product will not be accepted in market and the business may lose to competitors. Now let us check if we have understood the various concepts discussed in this lesson clearly. Cost control is a planned positive approach to reduce expenditure. Right or wrong? Wrong. Total Productive Maintenance (TPM) is a program which brings maintenance into focus in order to minimize downtime and maximize equipment usage. Right or wrong? Right. Value engineering is a systematic method to improve the value of goods or products and services by using an examination of function. Right or wrong? Right. Before we end, let us briefly revise what we have studied till so far. Value analysis is a technique with immense possibilities and systematically employed. it can achieve great economies and increased efficiency. Waste is defined as the substances having no value. Waste has no value, but it can create a problem for its disposal. From the costing point of view, waste can be of two types. First, normal waste, and second, abnormal waste. Reengineering is the key that every organization should possess to attain these prerequisites to success. Leadership, organization, cultural, and people issues have been identified as the major obstacles in achieving BPR success. Within BPR, there are numerous activities and decisions to be made, and most of these will have an ethical dimension. There are issues relating to both the process and the outcome of BPR. Organizations considering undertaking BPR, as well as those in the process of a BPR exercise, must temper their actions to ensure that BPR is ethically sensitive, thus increasing the probability of achieving genuine success for the greatest number of people. Total Quality Management (TQM) is different from the old concept of quality because its focus is on serving customers, identifying the causes of quality problems, and building quality into the production process. Quality Function Deployment (QFD) is a tool used to translate customer needs into specific engineering requirements. Reliability is the probability that the product will function as expected. Control is the process by which management ensures that the company conforming to prescribed plans and policies in working towards the attainment of corporate objectives. The approach to cost control that is based on the concept of responsibility accounting involves designing the cost control system to match the organizational structure in order that it reflects realistically the responsibilities of departmental managers, supervisors, etc. Cost control and reduction refers to the efforts business manager make to monitor, evaluate, and trim expenditures. Cost reduction can be achieved either by reducing capacity or drive savings by improving efficiency.